Hey everyone, it's Ben from Board to Bits, and welcome to part 32 of our series on making a custom character controller in Unity. This is the final video in our series, and today we're going to be talking about a couple of bug fixes or optimizations for our character controller system. As well, I wanted to have a quick discussion at the end of this video about our input system as compared to Unity's built-in input and why we approached this project the way we did. So let's get started. Part 1, exiting the vehicle. So, in our scene right now, we can have our walking controller walk up to the vehicle, enter it, begin driving around. We can maneuver around these obstacles, move all the way to the edge of the scene here, we can hit the brakes, but then if we exit the vehicle, we appear right back where we started. And if the purposes of a vehicle is to move your character around, this is really just a crappy implementation. So let's start to fix this. What's important to realize here, though, as we're seeing in this example, is that our walking controller is not being moved by the vehicle controller. If you'll recall, what happens is we deactivate the walking controller in the scene and simply put a model into the vehicle to drive around with. So what we need to do when we exit the vehicle is find a spot to move the walking controller character to, and then reactivate that controller. So we can do this by jumping into our scripts and into our vehicle controller script in MonoDevelop. And in here, I want to add a new stat in here, which is going to be called public float exit distance. And what this simply does is sets how far away our character is going to appear from our vehicle. I want to make it public so that we can adjust it for feel as we're going in case we're making the character appear too far away or too close to the vehicle. But I don't want to hard code it, so we're going to make this a little bit easier for us to adjust if we need to. We'll start it at 2. 2 units seems like it might be okay, but we'll see how it goes. So we'll add that in there. Now, what we're going to be doing, and what's nice about how we're going to be doing this, is that we already have access to our exit controller, meaning that walking controller, the controller we're exiting to, we can then access the controller and thereby its transform so that we can reposition it as we need to. And we're going to do that down in our exit function. Scroll down here right now, all we're doing in our exit function is simply activating that walking controller. Now what we want to do is reposition it first. So we can say exit controller dot transform. Remember, every mono behavior gets access to that transform component, so it's nice and easy for us to do. Dot position equals, and now we need to set up some way of determining where our, we want to find a position within the vicinity of our vehicle so it looks like we're leaving our vehicle rather than just appearing in the middle of nowhere. So we can start out by let's just start out with the vehicle's position. So we'll say transform dot position. And now, how do we want to offset this? I think what makes the most sense is to pretend like we're leaving from a door in the vehicle. And I'm going to go by the kind of American-centric approach of saying that the driver's side door is on the left side of the vehicle. So how do we know what the left side of the vehicle is, though? Because we can turn our vehicle around, we can steer it in any direction. So we don't have a way of, we can't automatically just say, oh, vector 3, vector 3 dot left is always going to be to the left of the vehicle. If we turn it around now, it's suddenly to the right of the vehicle. It doesn't make sense. However, Unity gives us a very handy tool, which is that the transform component has 3 directional vector 3s built into it. It has a forward, a up, and a right vector 3. And this is the custom right vector 3 based on how that transform is facing right now. So that will always be, in this right here, what we have right now, this would always be facing to the right of the vehicle. Now we want to multiply this by our exit distance. But bear in mind now, we're putting this character to the right of our vehicle. If we want it to be to the left, we have a couple of options. One thing we could do is we could actually make that number up in our variable negative as well so that it goes to the left instead of the right. Or we can simply multiply that. If we know right now we want to just pretend that we're always going to be exiting to the left, we can simply make that exit distance a negative number here by applying the negative sign to it. So that gives us the basics here. We can now go back into our game, hit play, And now we'll see that if we go over to our vehicle, enter it, we can once again start driving around here, go over into the kind of the corner of the scene here somewhere, hit the brake, and then exit the vehicle, and we appear right next to it, just like we want. However, there's still a couple of issues with this system. I'm going to reset the scene, because the first one I want to show here is that if we move over to this vehicle and get inside it, what happens if we drive up to, say, somewhere like right here, where now we have this box right next to us? You know, what's going to happen to our character? It's going to try to make it appear right inside of that obstacle. And the problem is that because that obstacle has a collider on it as well, they both can't exist in the same place. And what's worse, from what I can tell of Unity's physics system, it's going to try and push our character out in the path of least resistance, which is going to push it right down and out of our scene. So if I try this right now and I hit the exit button, we should see, well, actually in that case it just got kind of lodged into the block, which is also not adequate. I can't actually move this character around right now. I can maybe try to get back into I can get back into the vehicle, but really that's not optimal. And I've definitely seen situations before. I can try, in fact, to maybe go to another block here where it actually just pushed me right out of the bottom of the scene to like plummet forever into the void. Let me try this one. If this one doesn't work, we'll just move on. No, that one just pushed me out, but it's not an optimal situation. So how can we fix this? So the easiest way for us to solve this is to do a quick sanity check before we push our character out of the vehicle and say, is there something obstructing the exit space? And we can do this by jumping back over to MonoDevelop and into our vehicle controller. And instead of just simply automatically moving our character to this exit position, we can do an if check and say, if there is space here, then we can exit the vehicle. And because that's going to make this a little bit more complicated, I'm actually going to move this to its own method, which I'm going to call it's going to return a Boolean. So it's going to actually tell us, hey, this is true or false, there is space or there isn't. I was able to move the exit controller or I wasn't able to move them. And then we're going to just simply call this something like place driver. Doesn't need any parameters. And so in here, we're going to first set this potential vector 3 that we're going to move our character to. We're going to call this vector 3 potential exit point. We're going to set that equal. We'll copy this information here and paste it in. Now what we can do is check, is this space currently occupied by something? And Unity provides us with a handy tool to do this, which is in their physics namespace, they have this handy set of things called overlap shapes for a categorical name to them. But they're basically these things like an overlap box, an overlap capsule, or an overlap sphere that just kind of creates this invisible boundary in the world and says, are there any colliders in here already? So let's go with the overlap box, and we just have to give this some information. The first thing is going to be the center of this box, and that's pretty much going to be the exit point. We need to modify it a little bit though, because we want to make sure this box is a little bit above the ground so it doesn't detect the ground and always say, oh no, there's something in the way because there's ground there. So we'll simply say potential exit point plus vector3 dot up. And we can actually just leave it at that. Our obstacles right now are big enough. You may want to multiply this by like something like 0.6 or even maybe make it even higher, depending on how big your obstacles are in the game. But for right now, this will work fine for us. The next thing we need to do is add what's called these half extents, which is basically how far from the center of this object is the top, the top and bottom, the sides, and the front and back. And so because we just have a cube right now that's of size 1, it's going to be simply half of that. So we can say vector3 dot 1, meaning 1 on all sides, and then just divided by 2 because we're going from the center and not the entire width of this box. So times 0.5f. And that creates the size of this box. And that is actually all we need here. Well, that is all we need for the physics overlap box to tell it what size it should be. Now, the only other thing we need to check, the problem is that this doesn't give us, if we look here, overlap box doesn't give us a true or false. We can't say if overlap box. However, what it does return us is an array of colliders. So we know that if the array is anything other than size 0, we know that there's at least one collider in the way. So we can simply say here, if physics overlap box dot length is greater than 0, then what this is telling us is that there is at least one collider blocking our potential exit point. So if this is the case, then we are not able to place the driver. We can simply return false and say, nope, sorry, didn't end up happening. Very sad about that. Otherwise, we can actually physically move our exit controller. I'm going to actually copy and paste this in here. So our exit controller's position is going to now be equal to that potential exit point. And we can return true. We were successful in doing that. We no longer need this line up here because we're kind of passing this responsibility to the place driver. But what we can say here now is if place driver returns true, if we were able to successfully do that, then we can activate our walking controller again. So with all of that, now what we should be able to do here is we can hit play. Actually, I'm going to add one more thing in here just so that we can double check that this is working, which is in our, if we do have obstacles in the way, I want to quickly do a debug.log to say something like obstacle in the way, so that we know something happened. Now we can hit play, go over to our vehicle, enter that vehicle, and now if we drive over to here again, and I hit the brake and try to exit, nothing happens here, but we see down here an obstacle is in the way. Now I can move past this and then get out here, and something a little interesting happens there. We see that I am, for a brief second there, if you look really closely, you can see I am able to exit after a while, but it keeps now trying to flip me back into the car. And that's because of another little bug in this exiting the vehicle system now. We didn't see this before because we were always being dropped off in the middle of the scene and far away from the vehicle, but when we reactivate that walking controller, the walking controller takes a look at what we're hitting on the keyboard. And what that also does is actually activates our walking controller's interaction hitbox, which then immediately interacts with the vehicle, snapping us right back into that vehicle. So if I enter the vehicle, hit exit again, now you see it kind of does that snapping thing again until you maybe get lucky enough that it breaks away for some reason. Again, not an optimal system. A couple of ways we could solve this. We could have it so that the player character always points away from the vehicle when they exit. That gets a little bit complicated because you're dealing with rotations and vector 3s and figuring out, which direction the vehicle is facing. So we're going to do this a little bit easier by what we're going to simply say here is instead of that, we're going to say just deactivate the vehicle's controller for a frame so that that same frame, as we leave and activate the walking controller, we're not colliding, our interaction box is not colliding with the vehicle anymore. So all we have to do for that is in our deactivate script right here, we're going to just quickly put in something that will deactivate the collider for one frame. And our safest bet for this is a coroutine, which can simply deactivate the collider, wait one frame, and then reactivate it. So down here, after our place driver method, I'm going to add an I enumerator, which is the return type for coroutines. And we're simply going to say pause collider for the name. And all this is going to take is it's going to get our get component collider dot enabled, set that to false. It's It's going to yield return null, which is basically coroutine speak for wait one frame. And then I'm just going to copy all this. So here, I'll scroll this up a little. Copy all this again, paste it down here, and then re-enable the collider. And now, instead of having this comment here, we can actually say pause collider. And with that, we can go back over to Unity and hit play. And what we should see now is that we can enter our vehicle. We can drive around a little bit here, still facing pretty much the same direction, so that when I exit the vehicle now, I'm going to be pointing right at the vehicle, but I am not interacting with it. Now there's one other quick thing I'm noticing here. Oh, why now it's still doing that? That is doubly weird. And I wonder if that's because it is dumping me. If you'll notice there, I seem to like kind of rise out of the ground a little bit. And I know why that is, and I'm going to fix that right now. It's because the position that we have this in is actually right at the ground, and I believe our pivot on our player is centered in the center of the player, not the foot of the player. Let me focus on him there. Yeah, that's exactly why. So what I can quickly do here, and this should fix this, is when we place the driver now, instead of placing it just at the potential exit point, I am going to, similarly to how we added vector3.up, in fact, I'm just going to do that exact same thing. Copy that and paste that in here. We'll actually be a little bit above the vehicle and then float down, but that I think works fine here. It actually gives us a little bit more feedback. So one last time. Go over to our vehicle, enter it, drive around a little. We're still in roughly the same orientation, so we'll definitely be facing the vehicle when we exit, but now when we exit, we don't interact with the vehicle because it's losing it. That interaction hitbox doesn't have anything to collide with because the vehicle's collider is off for that one frame when we do the swap. So that covers vehicle exiting. We have a much more kind of realistic system of how that would happen now. So now we can move on to our next optimization. Part 2, attacking and interacting. So in our vehicle controller section of this series, we ended up switching our interact object class into an interactable interface so that we could combine these aspects with things, so we can make an interactable controller in terms of that's how we access our vehicle. The problem is this left our player hitbox system, which kind of detects what's interactable and what's attackable, with kind of a hacky system. If we jump over to monodevelop and look at our player hitbox down here, we now see that we have this sort of a system where in one case we're looking for an interface, in another case we're looking for an attackable object component. And likewise, right now, we couldn't make an attackable controller for the same reason we previously couldn't make an interactable controller, because you can't inherit from both of those classes. So what I want to do now is look at how to make attackable an interface like we've made interactable, and then kind of quickly see how this can create, make it a lot easier for us to create interactable and attackable objects, and even ones that are both at the same time. So to do this, we're going to create a new class in our scripts folder, and I'm going to call this iAttackable. Remember that putting I in front is just kind of a best practice for interfaces. It lets the other designers in that know that it's an interface. We're going to open this up in monodevelop. We're going to, instead of making this a public class that inherits from monobehavior, we're simply going to make this an interface called iAttackable. And we can delete both start and update in here. We no longer need those. However, much like our interface has void interact, we want to make sure that our attackable object has this take damage method in it. You can add other methods too if you want, but really the only one that in this example I'm requiring any iAttackable object to have is the take damage method. So I'm going to copy and paste this in here, and we don't actually put in the brackets because we're not defining this at all. We're simply making it a just kind of a template that is going to exist in any object that implements the iAttackable interface. So we can save that now. Now the other part of this that's a little bit weird now is that we, in a way, don't really need this elaborate physics layer system that we had before. What we can really just do, instead of having to check, oh, are you on the attackable layer or are you on the interactable layer, we can just have one general layer for any kind of interaction and then just check what interface it's implementing. So pretty easy for us to do at this point. We just kind of have to take a quick step back here, go Edit, Project Settings, Tags and Layers, or is it Tags and Layers? Yes, Tags and Layers. And we're going to get rid of the layer 10 and 11 here, which are the attack target and player attack layers. And all we need now is this player, what I'm going to now call player interaction and interaction target, because I don't want this strictly to just be the interact action. It's going to be whether it's interacting or attacking. So kind of making that word a little bit different there. Now the other thing that we no longer need to do is in things like our attackable object, which we do need to make sure it implements iAttackable, this no longer needs to go to layer 11. Now we want it to be at that layer 9 to be an interaction target. Finally, our player hitbox, currently we have it setting up where it checks at this point here and saying, oh, is this an interaction action? Then I need to be on this physics layer. Otherwise, I need to go to this other physics layer. We don't really need to worry about all that anymore. We now are always going to be going to layer 8, regardless of the type of interaction. And so we can actually move this. We no longer need to do this every single time we check for a collision. We can cut that from here and just put that up in our awake function. So right at the start, it's going to the proper layer, and then we're good to go for the rest of the game. Lastly, down here, now instead of checking are we getting a interact object or a attackable object, we can just check if it implements iAttackable. Now this is a little bit, actually we do have to do one more check here, because if we were to do this right now and we walked up to an interactable object and tried to attack it, it would go through this point here and say, oh, there's nothing there, or that's, it's returning null, and then try to get the method from a null object, and it's going to throw us an error. So we do need to quickly just double check that this exists beforehand. So we can say and call.getComponent iInteractable does not equal null. And that will simply tell us, oh yes, there is an interactable, there is a component that implements the interactable interface here. And likewise, down here, we can just say, otherwise we know we're attacking, so we don't need to check the action type, but I'm just going to copy this here and say, let's make sure that we at least have that iAttackable interface. So as long as there is an iAttackable interface, then we can do the take damage method that we know is on that object. So we'll save that there. And now we are able to have objects that are both attackable and interactable, which is pretty cool. We should see that this still works the same way now. We haven't affected anything in terms of interacting with things, so that all works. That's good. And likewise, I can walk up to this object that is not attackable, try to attack it, and I don't get any errors. But the other cool thing here is that I can really quickly now create an object. Let's create a C# script. I'm going to call this crate. This would be a crate that you could, let's say you can, pick up and move it around in your scene, but then if you attack it, it gets destroyed. So you can maybe pick it up and try and use it as cover, but then if it takes too many hits, you no longer have that cover. So we'll just call this crate. open this up in MonoDevelop. We should be able to do this pretty quickly now that we're implementing these interfaces. So we'll say interactable and attackable. Save that. Can delete the start and update function. I don't think we'll need either of those for this. And instead what I'm going to do here is I'm going to quickly say, if you right click, the other nice thing, is it right click? Huh. Version control, insert template. They're used. Can I right click on the, oh, that's why. If you right click on these interfaces, you can say refactor and then implement the interface. And what it will do, might give you an error. You can just say, yeah, use refactorings, that's fine. And then hit enter, and it creates the interaction for you, or creates the method for you. Now, in this case, what I'm going to do is I'm going to say if transform.parent equals null, is there a way I can automatically make this? What I wanted to do was make this a child of the player. Let me see here. Do we just got the walking controller there. Unfortunately, I don't know for sure that we have a, I don't think we have an easy reference to the player. We would need to actually probably pass the player in. So I'm going to do a really cheap hack thing here. And I'm going to say, if the transform's parent equals null, then the transform.parent is going to instead equal camera.main.transform. So what we're actually going to do here is we're going to child this crate that we're creating to our main camera, to our walking controller's camera. I'm going to quickly tag this as main so that we'll get that camera as our main camera. And so it's going to kind of appear that we're picking up the box and the box is moving along with us. It's actually moving along with the camera in this case. And otherwise, if we interact with it, then we'll simply set transform.parent back to null, so we kind of drop the crate and can move around again without it. Likewise, we want to implement our attackable interface. Once again, we can just right-click attackable, choose a spot for it. I'll do it down here. You don't really need these regions, but I'll just keep them for now. They're not hurting anything. And now for our damage, all we're going to say here is, we're not going to actually worry about the amount of damage. I'm just going to automatically say destroy game object. So now we can quickly add a cube to our scene. Oops, I didn't want to add it to the camera. Down here, height of 0.5, we'll put it on the ground. Where is that cube? Oh, wow, it's over here and it's all tilted and stuff. 0.5 for the height, so it's on the ground. I'm going to move it back this way so it's a little bit closer. And we'll just give it the vehicle material so it's a different color. Then the ground, we hit save, and we're going to add a quick crate component to it. And now all we have to do is hit play here, and what we should see is that if I walk up to this now and I hit Z to interact with it, it doesn't work, and that's cool too. Oh, because I never, haha. The one thing I forgot to do, I do need a void awake function, because much like our attackable object, I need to make sure that its physics layer is set to game object layer 9. And that unfortunately is one thing that doesn't really automate in this system, But like I say, you're still, like, within 5 minutes, I was able to create this object that's going to have these two interactions available to it. So now I hit Z and I'm able to carry this box around, not super elegantly at this point, but you get the idea. I can drop it again. Should be able to drop it again. It's interesting. It's for some reason not, possibly because it's a child. Huh, interesting. It is not colliding with its own children, which is, I suppose, useful in many cases, but not exactly what we're looking for. However, if we reset again and hit play, you can see that I can also destroy the box by attacking it. So, like I say, not a perfect implementation at this moment, but you've now got this ability to add interaction and attackability to objects very quickly using interfaces. So, that is and we're also not using an interaction system that's relying on these multiple physics layers and switching out these layers all the time now. We can just simply check for these interfaces and know what an object is capable of doing. Part 3, a word about inputs. So when I started this series, I really wanted to do a deep dive into how controllers work, starting from player input to the actual action in the game itself. And that's why I really started by diving into how input management works and how you really track input from a keyboard or a mouse or a gamepad, and then kind of package that up and then send it to a controller and that whole system. And I know that was a little bit controversial. In fact, I think I lost at least one viewer because I was kind of reinventing the wheel in a way. And indeed, if you look at Unity's project settings and go to input, you see that it has this structure here where you can look at, they call it axes here, but it's not just axes but buttons as well, and looks at certain things being pressed, are certain things are axes at a certain value, things like that. And if we look back at our input manager script, we have axes and we have buttons, and so it's very, like, it is a little bit redundant. But there's a couple of reasons that I wanted to approach it this way and really start from scratch versus just using Unity's input system. The first reason is that Unity makes it very easy to get input from pretty much any class or script that you're working on. As we see in our keyboard tracker here, all you really need to do to check for an input is just say like input get key and look for that key value, or input get button and look for a button name, and you can get that from anywhere. And the problem is this really decentralizes your input checks, because you can suddenly have a bunch of scripts throughout your game that are checking for inputs in different places, and then you don't really know why certain things are interacting the way they are, and you don't have one place to look and see what is all of the input that I'm looking for. So I thought this was a good way to really kind of understand that flow of input to game action, as well as to understand the importance of why you might want to kind of centralize your inputs and be able to see them all in one place. The other reason I wanted to do this is if you're working with a non-standard controller of some sort, particularly right now if you're working in VR, Unity's input system is very robust, but it doesn't really have a solution right now, at least, for looking for the, say like the HTC Vive or the Oculus Touch controller inputs. So you kind of need to build something like this for yourself in those cases. So again, I really wanted to kind of put that tool in your toolkit that you'd be able to build something like this if you needed to. So that being said, though, the Unity built-in system is perfectly valid and probably is a lot more efficient in a lot of projects. If you want to do something like this, you're perfectly able to you can create your own button calls and stuff right in here. You can use different controllers. You can have kind of secondary input systems depending on what you're looking for. So that is totally valid to do, and I would probably in 99% of cases recommend that, like I say, unless you're using a non-standard controller. But I wanted to give you that information. Now, this video is already running long, so I'm not going to dive into scripting and show how you could retroactively use this system with our current controllers. If there's a major call to see that happen, then I can maybe do sort of an appendix video to this series about that. But for right now, I think you have the basics, you understand where the controllers are looking for that button information, how the input manager kind of packages that information. So I think you could probably get started on that on your own if you needed to. So that will wrap it up for this series. Wow, we've done 32 videos here. There's been a lot of content. For those of you who have watched through the entire series, thank you. I hope you've enjoyed it and gotten some valuable information for your game design projects. As always, you can subscribe to the channel for future videos and series, and if you would like to support future series and videos, I encourage you to head over to my Patreon page to become a supporter there. And with that, I'll just say thanks for watching, and I'll see you next time.